falling into the sea, which obviously isn't great. So what we did is we built a beach, and we built a really steep beach. It's sort of at that angle. So the waves will come and crash against the beach and come back down from the sea, and they won't hit the cliffs and they won't hit the houses. So we've protected the houses, and then also everyone's really happy because they've got a nice shiny beach. And it's just huge scale. So there's a picture on the left which shows what we call rainbowing. So we're building into the sea. There's nothing to build on. So we throw sand out to create ourselves a platform. And then on the top right, you can see this huge machinery and these 6, 8, 10-ton rocks that they're moving. So just huge scale, quite interesting. And in this one, I was doing kind of night working because you've got 6 hours where the water's low enough to construct. So it doesn't matter if those 6 hours are, you know, in the middle of the night. If you've got to start at 1 a.m., you've got to start at 1 a.m. And the interesting thing about this project is it got a bit political. So this is David Cameron, who is the previous Prime Minister, who came down to site because the area was in a bit that was about to go to the UK Independence Party. So he really wanted to kind of make an impact and things like that. So he came and visited the site, which was one of the biggest projects in the area. The next thing that I absolutely love about my career is being able to travel. So this is in Tanzania. It's an irrigation scheme. And it's a project in the US which basically said we can fund these farmers to grow at least enough rice and maize. Like they might not have vegetables and they might not have the fancy stuff, but at least enough that no one's going to go hungry in Tanzania anymore. So that was the project, to get enough water to these farmers so that they could do that. Another one was Myanmar, which used to be called Burma. So this is another irrigation scheme. But the problem here is all the farmers live below the poverty line. Like they can grow rice, but rice doesn't give them enough money. And the water is so unreliable. Like one day they'll have completely flooded fields and all their crops will be destroyed. The next day there won't be any water at all. You know, the rich farmers will have all of the water and they'll just let it all go. And then the poor farmers' crops will all be destroyed. And there's no accountability. So by sorting out this scheme where we can get the canals to get the water to them, it meant that they can grow like vegetables, tomatoes, you know, cotton, and actually make a living income for them and their families. Then Bangladesh, oh, too far. The project that I was saying about, oh no, I haven't quite worked out where to click on this. Okay, the other one was Bangladesh, but you've seen the video. There you go, thank you. Sorry, every sort of 5 times I click, it only seems to click once, so I haven't quite got the hang of it. So the next thing was about COVID-19. So the interesting thing was I was still working on this Bangladesh project. Like I was out there for a couple of months, I came back for a couple of weeks and then got stuck here, so I couldn't go back. So I had to work from home, even with the people in Bangladesh. So we were sort of WhatsApp calling each other. They worked from Sunday to Thursday, so I was trying to do that. Like I was trying to start earlier in the day, and it was surprisingly effective. Actually, it did kind of work. We managed to make it happen. You know, with photographs and little videos and things to try and work out what was going on out there. And recently, I've been working on a construction site in Boston, up in Lincolnshire, and it's been great actually, because as much as COVID's going on and lockdown's going on, you're just outside. You hardly know it's there because you're in these vast expanses. It doesn't really matter. They check your temperature in the morning, but other than that, it's fine. And I just wanted to make the point that a lot of my civil engineering colleagues haven't had any change. You know, like it's quite a stable job, even in this kind of pandemic. Like I don't know anyone who's unfortunately lost their jobs. And a lot of them are classed as key workers. So if they're working in water supply or energy supply, so they've just carried on. They've been able to go out to the office, they've been able to go out to site. They haven't really felt the brunt of lockdown in the same way. Oh no. Thanks. And then just a bit of advice. So one of the things that really clicked with me just before I picked civil engineering was I heard that to have a fulfilling career, you need 3 things. You need autonomy, mastery, and purpose. Autonomy is like being able to do what you want, like choose what you want, like day to day. And so that's what I was saying. Engineering, like you can be in an office, you can be outside, you can travel, you can not. That's fine. Mastery is like being really good at something, you know, being like a world-class expert in something and feeling like you really know enough about something to be an expert and to make a difference. And again, in civil engineering, you know, we have people in our company who are world experts in different things, and people will contact them from any country in the world and say, I need advice on this. So that's quite interesting. And the next one is purpose. So again, with engineering, like really feeling like you're making a difference. Like these farmers, or this project in Bangladesh, we said that we're making a difference to a million people. Like a million people are going to have less flooding, and they're going to be able to keep their homes. It's just huge numbers. The next bit was that university selection, as I understand it, isn't that important to recruiters. So like find a university that works for you, but make sure you get your extracurricular. So if you're interested in international development, then join Engineers Without Borders, or like, you know, try and get work experience if you can. That's what they look at. So yeah, make sure the university works for you. And yeah, that's it really. That's the end of my presentation. Thank you. Sorry about the technical mishaps.
Awesome.
I missed some of it.
No worries, no worries. We can ask questions and we can have a Q&A session at the end. So thank you so much, Hiba. That was really, really inspiring, especially just how you can use an engineering degree or engineering to empower people from developing countries. So, and also travel. So that's quite exciting. Yeah, moving on. Second, we have the magnificent Ola El Hassan. Ola is an electrical engineer with experience in electronics, power systems, communication, data science, and software engineering. Her degrees cover power plant automation, aircraft, space, and wind turbine control. She's been at Arup for 3 years designing electrical systems for mission critical and commercial buildings like hospitals and data centers. Ola is also a poet seeking to bridge the gap between her creative and engineering careers. So thank you, Ola. Take it away. Do you want to request control and then?
Yes.
Yes.
Hi everyone. Thank you, Mariam, for that beautiful introduction. Okay, so just like Hiba, I think I'm having a hard time moving. Okay, cool. Day in the life of an engineer. I think I'm going to start just going through how I ended up studying what I studied and what came from that. So I am from Sudan. So I did my bachelor's degree in Khartoum at the University of Khartoum. It was a degree in electrical and electronic engineering. So when we started off, we got the privilege to study so many different subjects, everything from organic chemistry to power systems, communication, so how antennas work, software engineering, so learning how to write code to make sure all electrical systems can work, electronics, so designing all the little devices, things that move around. And then I ended up falling in love with something called control engineering. I was on a visit at something called the National Control Center in Sudan. And I walked in and I saw that there was a big screen showing all of the electricity for all of Sudan. And people were sitting on their monitors. They were monitoring it to see if there was a problem somewhere far, far away in the country from where they were sitting. They were able to see what the problem was and to send engineers over to take a look and fix the problem to make sure there was still electricity. I thought that was really cool. So I decided that was going to be my focus. After I graduated, I spent a year in Khartoum as a teaching assistant. So helping out students and teachers to finish up their courses, just like I had the year before. Then, trying to move. Then I moved to Copenhagen, which is where I'd spent the first 12 years of my life. I went back there so that I could do my master's degree at something called the Technical University of Denmark. Now, that is a picture from our library, and we had an old aircraft that was operational for a couple of years. It was just hanging there, and I thought that was really cool. So I got to study a lot of really amazing things at the Technical University of Denmark. And we got to understand spacecraft and how to design all the different systems that go up into space. We got to learn about robots, how to make them, how to help them understand things like path planning and how to move around. We got to learn how to make sure that an aircraft could move without like shaking all over the place. So that's where we designed the control system for it. And the same for unmanned aerial vehicles. So that includes drones, but also underwater vehicles. And again, I did a lot more control, some theoretical and some in the lab, trying to design things like little motors that stop buildings from shaking too much if there was an earthquake, and lots more automation. So when it comes to automation, that can be everything from your kitchen to your lights to how a power plant generates electricity for the country. It's just about making sure that it can work on its own and that it's able to, via sensors, measure all the different things, even in a factory. If you're making juice, it makes sure that the tanks don't overflow and that the valves close when they need to close, things like that. So that was really exciting. After that, okay, so this is, sorry, going back a slide. So this is going back a couple of slides. Okay, so this is a picture from, oh, sorry.
Let me
yeah, sorry, Miriam, can you go back to the picture with the two robots? Yes, thank you. So these were our little robots that we got to work with while we were at university. And this was for a competition where we had to teach the robot how to go into that little maze. I don't know if you can see, there's a little maze made out of some wooden planks. And without it memorizing what the maze looked like, to be able to go in and not crash into the walls. And then we used the camera that was attached to it so that it could read those little white pieces of paper with black blocks on them, and then it would tell us what those black dots are trying to say. So that was a little bit of coding. And then we also learned how to throw some blue tennis balls and red tennis balls at it, and then it would avoid them and would be able to tell us how far away from them they were. So how far the ball was from the robot, and also what color the robot or the tennis ball was. That was also a lot of fun. Then I moved to London, and I realized that electrical engineering has so many different aspects to it. And I wanted to try something called data science because I thought it was really cool. It's basically understanding all sorts of random information and trying to understand the different relationships between them. So you can look at correlation between things you maybe thought were random, but turned out to be not so random at all. So for example, why people like to eat ice cream in certain countries. And then you can look at all the different information and realize that if it is a hot country, they probably like ice cream more than if it's a cold country and things like that. I spent some time doing that, but then I realized that I wanted to go back to a little bit more engineering. And then I joined Arup. Now, Arup is a very, very big firm. So we have offices all over the world. And this is where I met Miriam and Kundai, who you'll hear from later. But I also got to do some really amazing things with people I met there, including having an event with Akala, who is a rapper and a novelist and all sorts of things. He's also a historian. And it was, we did an event around how to empower Black people to make sure that they get the most out of life. And I also got to, with Arup, I joined the graduate program. So one of the best things about engineering is you realize that once you graduate, there are so many different ways that you can further learn while working. And I joined a graduate program where we got to do things like going on manufacturing placements in places like Helsinki. And we got to go and visit facilities, but also we got to go and see buildings that were designed by our firm, like this library here. Now, there's a picture of us. So what do we do as projects? Well, we design everything electrical that goes into a building. And that includes doing calculations, understanding the built environment, who uses it and why it's used. And we also learn how to use some really cool software so that we can build these 3D models. Now, usually when you see a building, you just see rooms that people live in or work in, but a lot is hidden behind it. And that's where mechanical, electrical, and public health services come in. So that's everything from cables to generators, if it's a big building that needs a generator, and all the pipe work that might be hidden in places that you wouldn't even notice. Everything that you see here on this screen is mechanical, electrical, public health equipment in a very important building called a very important lab building, and we classify those as mission critical. And that's because if the power cuts to it, or if the mechanical systems aren't able to move the air around the way that they should be, then you have problems like temperature affecting all the experiments that the scientists are doing, and you might have issues with some very dangerous pathogens moving from one room to the next where they're not supposed to be. So this is one of those buildings. And I think I have another picture of it. Yes. Oh, sorry. Going back. There. Okay, cool. So this is another picture of another floor in that same building, which has a lot more equipment in it. And next to it is a picture of something called a switchboard. Now this big orange switchboard is what you see as little orange boxes. And it's basically a larger version of the little consumer unit that you have in your house with all the little fuses that make sure that electricity comes into the house. Now for big buildings like labs and hospitals, those consumer units are just a lot bigger, and sometimes they can look really pretty and be orange. And I really like this project because of that. Now, I also do poetry. So I think it's really important for us when we decide what we want to do with our lives that we don't limit ourselves to one or the other. So you can be creative and you can be an engineer, you can be a poet, you can do music and you can do mathematics, all of these things. So make sure that you follow the things that you enjoy and you don't let anyone tell you that you have to do either or. And then somehow one day you'll get to work on both. So one of the things I'm excited about now is I might get to work on designing buildings that are used for things like theater and concerts and things like that. So that's also super exciting. Now, when it comes to COVID, so a lot has changed. We don't get to go to site as much as we used to, but we're able to still design buildings because we have all this, you know, like what I showed earlier, the 3D software. So as long as you have a computer, as long as you're able to talk to other people, which we're doing by things like Zoom and Teams, then you'll still be able to design all the buildings that you want. And in the meantime, you also get to spend a lot more time doing other things like reading, drawing, and taking care of plants and things like that. So that's been the experience throughout COVID. And yeah, thank you so much.
Thank you so much, Ola. That was so nice. Yeah, that was really inspiring. I really liked how you showed the several different paths that engineering can take you into. It can take you into being a data science, you can be an electronic engineer, and I just like that how you spoke about bridging creativity and engineering, because that's definitely something that I've struggled with when I was younger. I did art A levels, but then I also did maths and physics, and I wanted to always make sure that it was bridged. So that's definitely possible, and Ola has showed us that. Okay, so next up we have the amazing Kundai Zibanda. Kundai is a structural engineer who has been working with Arup for almost 2 years since graduating from the University of Birmingham with a master's degree in civil engineering with industrial experience. Kundai has always strived to find opportunities to best use his abilities as an engineer to make the world a better and more sustainable place. Through his involvement with engineering non-profit organizations during his studies and within his current role, where he actively tries to implement the UN SDGs, which are the Sustainable Development Goals, into his work. So thanks, Kundai.
Thank you very much, Miriam. Yeah, I'm conscious that my internet at home is a bit iffy, so I was wondering if I could share my screen just to make it easier when I'm flicking between different slides. Is that okay?
Sure.
Cool, I'm just going for it. Okay. Let me know if you guys can see that.
Yeah.
Sweet. So hi guys, yeah, my name is Kundai Zibanda. I am a 24-year-old structural engineer. I work with Miriam and Ola at Arup. And I thought I'd just give you guys like a bit of background as to how I actually got into engineering and how that path has been for me. And yeah, so far just start from the very beginning, I guess, not very beginning, but far back enough. So I actually spent the first half of my life living in Zimbabwe, which is here in Africa, and I moved over to the UK in about towards the end of 2007, when the financial crisis was happening and there was a whole lot of political mess, and I thought it was just easier for my upbringing just to move here where it's more stable. And I came here, and as soon as I got here, I started year 7 the week after, and yeah, it was a very weird adjustment, but got through it, and I made it all the way to year 11, where I did all right. And I went to do my A levels, and I studied maths, physics, chemistry, and geography. I always had a clue that I was going to do some kind of engineering, but wasn't really sure. My dad was a civil engineer, and so a lot of my cousins. So I kind of had an idea that was going to point towards that route. I was very fortunate that in the sixth form I went to, just off by chance, I had I went on a school trip with one of the classes I was in, and one of the teachers had a friend that worked at Arab, and just in passing, I mentioned to her that I was really interested in engineering, and she said, "I've got a friend that works there, and they kind of managed to organize a week experience for me, week of work experience for me there," and that changed. That basically solidified it for me that yeah, this is what I want to do, and I actually got an opportunity to go back after I finished my A levels to do another work experience week with them, and I actually got my opportunity to go on site with Arab. So I'll move that here. So yeah, I got an opportunity to go to Crossroad Place, which is in Canary Wharf. I actually got to see it getting built before it looks like this, and it's really it was really good for me because I could look outside my window and see it, and I got to see it develop over time, and I think that's what drew me towards engineering in a sense. So yeah, just seeing something like this come to life was like, yeah, I love it. So when I went to university, I did a master's in civil engineering with industrial experience, and I think Hiba very eloquently described what a civil engineering actually is and what it entails. And yeah, I really enjoyed the experience. And while I was there, in between my different, so after my second year, I had some placements with Amy, and the year after that, I had some placement with WSP, which were organized through the university. And while I was at university as well, I got opportunities to do a bunch of stuff. So I was part of the African Caribbean Society as the first year student rep and international student rep as well. So I got to talk to me and talk to a lot of people. But I think by far my favorite part of university was being a part of a society called Cameroon Catalyst. So while I was at university, I first joined Engineers Without Borders, and they had an affiliation with an organization called Cameroon Catalyst, who essentially do provide engineering solutions to rural villages in Cameroon, which is here in West Africa. So one of the projects that they were working on were relating to the provision of WASH, so which is water and sanitation systems. So we actually got an opportunity to go and help open up one of the wells that had been designed by the NGO. So it's a student-led organization as well. So it was really great that we did all the work, and we actually got the opportunity to go out there and actually see the difference that it was making in people's lives. We also got a bit of downtime to kind of just like engage with the community. And throughout the year, we had loads of opportunities to like fundraise towards the project. So everything that we were doing, we were raising the funds, we were doing all the designs, all while studying. So it really got me excited for my future as an engineer, and just be able to see how my abilities can kind of make a difference in people's lives. So that was probably the biggest highlight of my university experience. So yeah, towards the end of my final year, I applied for a graduate job at Arab. And I think thanks to all the stuff I was doing at university, I actually managed to get through the doors. And as soon as the summer vacation finished after my final year, I got a chance to start my job at Arab. And one of the first things that I worked on was 3 Broadgate Circle. So this is a project which is just in Liverpool Street, Bishopsgate near Liverpool Street. I like to think that without me, this project would not have been as successful as it was. I feel like I made a very big impact. So if you guys look closely at this really nice building, the part that I worked on was this little black shutter gate. So in reality, it was just like a goalpost. So all it did was just provide something for the shutter gate to hang off, but it was a curved beam. And I was super proud of it because it was the very first thing I'd ever designed as an engineer. And there was a lot of pride in that moment. And I felt like, yeah, this is something that would bring me joy. And I was very reassured in my career. And was a really good learning opportunity for me as well, because I got to learn a little more about the subject, and I felt very supported by all the engineering colleagues I had as well, because when you first come out of university, there's no expectation for you to know everything. So asking questions is very much encouraged. And I did a lot of that at the very beginning of this project. And after that, I was trusted enough to then be put on another project, which is one I'm still working on now. So I've been working on this project called Skylabs since November 2018. So it's coming up to about just 2 years now. So yeah, just about 2 years, which is just like less than 10% of my life. So this is a building in Osterley, which is like near Heathrow. It's a building for Sky. They're the client, and it's designed by Atkins, who's also the architect. There's a whole bunch of different stakeholders involved in this project, and with stuff like this, it gets quite pricey. So this has a budget of about £70 million, and which is why it's taken so long to kind of build. I'll just go through the project itself. So it's a 3-story commercial office with a steel frame, columns, and framing system with concrete decking. This is just what it looks like on the inside. And as a structural engineer, you look at this and you think, wow, the engineering aspects are really blended well with the architecture, which is what I really like about engineering, in the sense that it gives opportunities for you to do that. So yeah, there's just some pictures of what it's supposed to look like on the inside. And a lot of this was through the input of myself and the rest of my team as structural engineers, working in collaboration with a whole bunch of people, such as the mechanical engineers, electrical engineers, and architects, just to make something like this come true. So this is what it looks like at the moment. This is me on site doing my social distancing and just making sure that everything is getting built as we intended it to. So it's been really great fun as an engineer just to see something that you've spent hours and hours on designing on a computer and paper actually come to life in reality and be able to touch and feel it. And yeah, but just to like kind of give a bigger perspective of what structural engineers actually do. So I touched on the fact that we work in collaboration with a bunch of different people to bring the building to reality, but there's a lot of detail that's tied into that. So at the very beginning of a project, as a structural engineer, what you do is you have discussions with the different stakeholders involved and see, if we were to design this thing, could we make sure that it stands up? That's probably one of the key things as a structural engineer that you're concerned about at the beginning. And you also have to go a step further and think, well, is this something that would be good for the environment? Can we use steel, timber, renewable materials to build it? How would we make sure that if we built it, all the other people that need to design components in this building can also do it well? How do you make sure that when we build it, we do it in a very safe way? We can build it in the time that we have been allocated by the client. How do you build it in a cost-efficient way? How do you make sure that we don't cause any problems further down the road? So there's a lot of thought that goes into the structural engineering process, and I like the fact that when you start off that process, you're pretty much starting off with a blank sheet with your architects and your MEP engineers, everybody involved, and then you eventually go from something that looks like this to having something that looks as ridiculous as this. So like I said, I've had experience as an engineer 2 years, and I've been learning on the job to kind of be able to read stuff like this. So yeah, it's been just really interesting to see how that project has developed from being something so simple like that to something as complex as this. So yeah, that's been a really interesting project for me. In terms of working with COVID-19, yeah, it's been hectic, just trying to adjust to things, but yeah, we find innovative ways to make it work. Just having a lot of phone calls with people. You do get the odd hours where you are having to work a bit longer hours, just because of the fact that you're in meetings a lot more. You can't have those friendly chats with people in just by coincidence. You have to actually make the effort to stay in touch with people. So that's probably been the biggest impact for myself. But other than that, it's pretty much business as usual. I'm actually back in the office now, so but there's less people there, and I think it's probably going to be that way for a while. And as you saw in that picture, I'm also trying my best to social distance and prevent any spread of the virus. And in terms of any advice I could give you guys, I think it's probably going to be aligned pretty much with the timeline I provided before. So I think at the very top of the list for me is networking. Yeah, again, it's not always what you know, it's who you know. With the work experience that I got before I got to uni, that was pretty much the best example I could give for that. And it's important to always maintain relationships with people, because you never know how helpful they may be in the future to you. So, or you could be for them as well. So always try and maintain your relationships. And again, when I was in university, again, I tried like a whole bunch of things, and I got to meet a lot of different people. And that opened up a lot of doors for me, because it gave me chances to diversify my skill set. If you look at the world 10 years ago, the kind of jobs that were around, the kind of jobs that are around today, like your Ubers, your Airbnbs, everything is different. Coding probably wasn't as big as it was today as way back then. So it's important to just open your mind up to different things, as trying as many things as you can. And yeah, ask questions, because it's better to ask questions and not know something than to pretend you do, and then something goes down further down the line. So always make sure you do that. And key thing for me as well, understanding from a very early point how you learn best. Do you learn best when you read, or when you hear something, or just by using your hands to do something? Having that knowledge from a very early point will kind of put you in the best position to just kind of get the best out of your learning experience. And yeah, also in school, you're probably going to learn a lot of things that aren't going to be useful to you. And so in some cases, it might be worth just memorizing those things, but you will go further along in life if you focused on understanding concepts rather than just memorizing. So yeah, that's it for me. Thank you very much, guys. I'll share the screen back with you. I'll stop sharing actually.
Thank you so much, Kundai. That was really great. Really like to see how active you were during university. It actually shows us that you don't have to wait to graduate to be an engineer. You can be an engineer while you're studying.
That's right.
Yeah, and it's also reminds me how much pride there is in actually seeing your work built, something that you've done that will actually stand for at least 50 years and probably hundreds of years. So that's really cool. And yeah, he does remind us that, you know, ask questions, and that's a reminder that we have a Q&A at the end. So if you do have questions, pop them in the chat, and we'll look at those at the end. But I'll share my screen, because finally we have the awesome Thaddeus Sumwa. Please correct me. And Thaddeus is a chartered chemical engineer with a master's from the University of Manchester. During his career, he worked in the UK, Spain, and the Netherlands in various operations and engineering roles. As engineering manager projects at Croda, specialty chemical company, he's currently developing strategies and delivering strategic projects, including a roadmap to help reduce operation emissions by 50%. So, thank you, Thaddeus.
Here we go. Right. Basically, I'll just introduce myself. Thanks for the great introduction. My name's Thaddeus Nimsamura. I'm working, as he said, at a specialty chemical company, and we make all sorts of stuff that goes into everyday lives. And this photo, I like it because it just shows someone walking in the fields. But actually, in this kind of photo of just nature, there can be actually already so much chemical engineering, and that's what one of the things that inspires me to be
excuse me, does that have to be Corona or just Corona?
Can we ask questions towards the end, please?
Sorry.
No worries.
Yeah, and Yeah, sorry guys, we're having a little delay with the screen. We'll get it going. But this is my first experience of engineering. Actually, was of engineering work was when I did a first year internship do my degrees. So I started studying in 2008, and after my first year, I managed to get an internship with Procter and Gamble in 2009, and that was on a Pampers factory making diapers. And it was a fantastic experience. I really enjoyed it. It was something completely different to what I was doing normally. It was all about optimizing the lines, the production lines that were going on there, and I kind of got a new sight on what a chemical engineering could be. And then during my degree, you learn a lot of the technical parts of chemical engineering. And when I finished in 2012, I decided to work for a specialty chemical company, which is a little bit further up in the chain. So a company like Procter and Gamble, or Unilever, they will be selling you your toothpaste, your shampoos, even your Pringles. But further up in the chain, there's all sorts of things that go into it. And it's kind of like the components that make up your phone. You have the same with foods. And I decided to work for one of these companies. And I started doing that. I got a graduate scheme, and I had a couple of different rotations. And in 2014, they after a lot of good work, they promoted me to take some extra responsibility, and then I started really kind of working on bigger projects, working on projects with a slightly different impact. So I started also working on safety projects, and moving on, going into that, I decided, hey, I've done a little bit of engineering. I want to try something completely different. I went into production, and I was a shift manager for a little bit. 2 years. I had a great blast talking to the operators, really working the night shifts, got involved with some of the manual work myself sometimes as well, and understood what goes on in the factories. And then just last year, I went back to engineering manager projects, and we kind of split it up, so we have an engineering manager that's looking after the day-to-day stuff, the maintenance stuff, and I'm looking more at the long-term innovation stuff, which is really my passion, to look at where do we want to be in the next 5 years? What are the new technologies that are coming out? I think the story of this for advice for anyone is really just follow your passions, but be completely open to trying new stuff. I think that's what one of the reasons that I decided, for instance, to be a shift manager. But following my passion is what brought me also back to engineering after trying that. And it's really important just to kind of keep your eyes open while you're doing it, because I've seen that sustainability is one of the major things that is coming up during my time earlier, and it was also a passion of mine, so I really tried to specialize in that and also learn a lot about it outside of work, and I was able to bring that back into work. So really just go for what you want. And here we go. Now, a little bit about me. I was born actually in Ukraine, believe it or not, but I'm Ghanaian by background. So I spent a lot of my life in Ghana before moving to the UK. And I did, most of end of primary school and secondary school in UK. And during university, I had a great opportunity to study abroad. That also brought a lot of insights in terms of different ways of chemical engineering. Over there, they do a lot more chemistry in their chemical engineering, and that really opened my eyes up to, you know, another component of it. And then I started working after my graduation in the Netherlands, which is where I'm based now. But I didn't stay in the Netherlands all the time. I actually went shortly to Spain. Also experienced another thing. Every opportunity that I got on, I just thought, let's go for it. Try something new, learn something new, and just to keep on learning. And that's kind of a message that I want to give to you guys as well. Just try and really enjoy learning and find something that you learn enjoying, and keep it going through your life. So this is a little bit of a path I went. You can see it's all zigzags everywhere. But what kind of stuff are we talking about that we're making so it's everything from products that are going into your face creams, but also into vaccines, into crops that are going into your foods, into plastics, paint, into cars, into cleaning stuff in your house. So it's really broad. You know, when you're brushing your teeth in the morning, you'll be using one of our products. Or if you've got a L'Oreal shampoo and you look on the back, there's a whole list of ingredients, and some of those will have been provided by people. And I'm in the business of really getting to the start and making the stuff that makes the magic happen. And so I don't do this on my own, of course. There's like 4,000 other colleagues around the world, and colleagues have all sorts of different roles. So there's some guys in sales, marketing, some guys really in production. So for instance, in COVID, the production guys, because we're critical to just life, everyday life. You know, you can't live without your soaps, your shampoos. But even we had products going into the COVID vaccines candidates, and into kind of hand sanitizer. So we were just full blast continuing the manufacturing. But those guys were just doing it in a different way with a lot of social distancing. I was more at home because I'm doing long-term innovation projects. I don't necessarily need to be on site. So the sales and marketing people were also at home. And for me, you know, I can't go into the plant when I was at home. So I had to start doing different things. So I had to start thinking about conceptual things. And it was just a new way of working. A lot of video conferencing, and it was quite nice. You still found a way to have that camaraderie with all these different colleagues that are, you know, some kind of feeling of one team going through a joint struggle. And this is, if you look more about what this kind of thing that can happen, you know, even your mobile phone can have some stuff. And this is actually just examples of products that I've worked on, because there were more previously. So you can see, like, some of them have gone into coatings for hockey sticks, but some of them have, you know, gone into stuff into cars as well, or into mobile phones. And this is the place where I work on. So if you know Gouda cheese, that's where the place where I work. It's but we don't make cheese, we make chemicals. So stuff comes on a ship and on a truck, and it goes all the way through our factory before it goes back out again. The main thing that I do really is about right now is about climate. That's the main thing that I've been working on. We've said we want to be climate positive in 2030. So, and that's all about the science-based target of keeping global warming to 1.5 degrees. And some of the projects that I've been involved in is we've, for instance, reduced carbon emissions in the Netherlands by 25%, got quarter back, and that was 1,500 houses or 12,000 tons of CO2 a year. And I was sponsored by the EU as well, because they thought it was a fantastic project. So, and other stuff that we're doing is now, what I've been doing during COVID is really looking at the current plants that we have, and just thinking, hey, how do we do it in a more sustainable way? But, you know, you've got to think about some other stuff as well. You've got to think about, for instance, carbon pricing coming in, but also in the Netherlands, they're going to phase out natural gas. So you've got to speed things up. And of course, you're thinking about more going to be available with the kind of digitalization happening. So that's the kind of stuff we're thinking about. And, you know, the current plant is using natural gas, and the new plant, you know, it's got to be 100% electric and carbon neutral. So what if it was that easy, we wouldn't have a problem, right? But electricity is double the price of natural gas, and that's why I've got a job basically to figure out how we make that possible to get to that carbon neutrality. So that was really a lot of big focuses on energy reduction, full energy analysis of what we're doing now, and just really just starting with a sustainable design. Just thinking outside the box is something that I would say that you've got to follow in your career as well. Don't let yourself be limited by what you do now. And for me, that's a wrap, really. I think I covered everything, but a little bit in mixtures as I went through. So I hope you guys felt a little bit inspired, got a little insight into the kind of stuff that a chemical engineer can do.
Thanks, Thaddeus. That was fantastic. It was really great to see how engineering, you know, helps in our everyday life. When we look at all the products we have in our house, we know that an engineer has been involved in the production of that. And it was good to see how we're trying to be carbon neutral, trying to reach our sustainability targets, because that's also important. It's nice to see that, you know, things like cheese, which I love, the process of producing that can also be sustainable. So that's really wonderful. So yeah, that brings us to an end of all of the presentations. And now we have a few minutes, a short while for some questions. We have a few
Wait, when will the meeting end again?
12:30, but we've got some time for some questions now. I've got a couple here. We're going to run through them really quickly before we end. The first one, I don't know who would like to answer this, but it's, what is coding?
So it's in the most simple forms, coding is a list of instructions that your computer can follow so that it understands what to do. So for example, when you have a keyboard and you punch one of the keys on there, the computer learns through the code that you write, the list of instructions you've given it in language that it understands, that if somebody presses a G, then it will show a G on the screen. So that's the very simple form of coding, but it can also become super complex, calculating a massive amount of numbers per minute that our brains don't know how to compute. So that's coding.
Fantastic explanation. Thanks, Ola. And also, to add to that, we have another event after this at 12:30 on coding. So do visit our website, afbe.org.uk/events, and you can register for that event. Secondly, this is directed to Hiba. Does Mott MacDonald provide training in maintaining, operating, and managing the irrigation infrastructure to the local communities? What were the challenges you faced to implement the project in the countries you worked in, Africa and Asia?
Yeah, so I guess as an engineer, we do a bit less of it, but there's a whole separate component on kind of how they're going to maintain it. Because the problem with irrigation all over the world is they'll spend hundreds of millions making a shiny new scheme, then they'll spend absolutely nothing for 30 years, and then they'll spend hundreds of millions making a shiny new scheme. So if it's better for them to just keep maintaining it every year. So they do a lot of training with the clients and the operators on, you know, how are you going to operate this? Then how do you do the basic repairs? How do you do the bigger repairs? And linked to that, I think the challenges were that a lot of people want the really shiny stuff. So like everyone's saying, you know, we don't want to do any work on it. We want everything to work automatically with robots and machines. And, you know, we're saying, well, you've got a bridge and you can't even fix this very simple bridge, which has, you know, which is very simple and very easy. So you can't be doing the fancy stuff. And then when it breaks, you won't have anything left. So I was trying to get them to kind of say, like, start with the basics, like, let's give everyone water, and then we can have robots and things, but let's give everyone water.
Right, get the priorities straight.
Yeah.
I agree. Next question is to Kundai, and it is, what happens when stakeholders reject your project?
What happens when, well, I haven't been involved in that part of the process as far, but I would imagine that, so the way the project actually comes is a client says they have a project that they want to put out into the world, they want built, and it gets bid for by different so as Arab, we would say we want to do that project, we bid for the project, but in terms of stakeholders themselves rejecting, I don't think that's probably how it works. So that's kind of answers your question.
I agree. I think that's more for a client kind of problem, client side, and getting buy-in from stakeholders, which could be government or, you know, local authority. But I think when you're a consultant, you're not really in direct contact with that sort of thing. Next one is very inspiring presentation to Thaddeus. It's just a comment. It's very inspiring presentation to Thaddeus, as learning is a lifetime journey. As engineers, learning is part of our professional development. And I think final question is a follow-up from the first, which is, what is binary numbers?
I know what they are.
Ola, do you want to answer that question?
Yeah, sure. So there are a lot of different ways that we can count. So the way that we know how to count most commonly is counting 1, 2, 3, 4. But then there are other ways where you just use zeros and ones and you group them together for them to mean 8 or 16. And the ways that you group them together there are a lot of different systems all over the world that have been developed a long time ago and new. But the one that we use when it comes to computers, that computers can understand best, are zeros and ones. So those are binary numbers.
Awesome, thank you. And I think that's the end of the questions. So that will bring us to the end of the event. I just want to say a massive thank you to our amazing panelists for sharing their wonderful engineering stories and taking the time to prepare for the event. I hope that everyone was inspired. I was definitely inspired. Please, as I said, please check out afbe.org.uk/events for our upcoming events. And as I mentioned, we have one that's starting now on coding. So for those who asked the question on coding, that would be great for you to attend. So yeah, that's it. And thank you for joining, and enjoy the rest of your day.